Now that we've defined our actions for creating and removing to-dos, let's see how to define a reducer that will keep track of the state of the to-dos in our application, as well as behave appropriately when our components trigger one of these actions that we just defined. First, let's create a new file in our to-dos directory called reducers.js. And this, as you may have guessed, is where we'll put our reducer code. So let's talk about what a reducer should look like and how it works exactly. Well, at its core, a reducer is just a function named after whatever resource in the Redux store it's in charge of managing. So for this reducer, we're going to define it by saying export const, and we're going to call this reducer to-dos. And reducers take two arguments. The first one we'll call state, and the second one we'll call action. And it's going to be a function. So here's how reducers work. Every time any action is fired from anywhere in our application, our reducer will get called. When this happens, the two arguments that will get passed to a reducer are the current state of whatever resource the reducer is managing. In this case, it'll be an array of the current to-do items in our application. And the second argument is the action that was triggered, which will be an object with type and payload properties. So what reducers do is take the current state and the action that was triggered and decide what changes should occur in the state as the result of this action. And they should then return the updated state, and Redux will take this return value and set the current state to that. Don't worry if that doesn't make sense quite yet. We're going to go into much more detail. So the simplest possible reducer for us would be if we were to just say return state. Since no matter what action or state this reducer was called with, it would make absolutely no changes. However, we'll usually want our reducers to be a little bit more complex than that. The actual meat of our reducers will almost always be a switch block that looks at the type of our action. So first, up at the top of our reducer, we're going to say const, type, and payload, and get those properties from the action that our reducer got called with. And then what we're going to do is have a switch block that looks at the type of the action and decides what to do based on that. So we're going to use this switch block to make the to-dos reducer respond correctly to our create to-do and remove to-do actions. In order to do that, we have to import the create to-do and remove to-do types. So import create to-do and remove to-do from actions. And then we're going to add cases to both of these action types to our switch block, and that'll look like this. We'll say case create to do and case remove to do. And now that we have that, we just have to think about what we want to happen to our to-dos state, which is going to be an array, remember, when either of these actions occurs in our application. Well, when a create to do action occurs, we'll want to get the text property from the payload, which will look like const text equals payload. And remember that we defined the payload like this when we defined our create to do action creator, right here. And the next thing we'll want to do is create a new to-do item, const new to-do, with the text that we got from the payload, as well as an isCompleted property that's set to false initially. And finally, we'll want to return the current state, which is an array of our current to-dos, return state, with this new to-do concatenated onto the end. So we'll say return state.concat new to-do. And note also that this concat method, when called on an array, doesn't actually mutate the array. When working with reducers, it's very important that we're careful not to mutate the state in any way, because this will cause problems down the line. So that's the logic for our create to do action. Let's do something similar for our remove to do action. For this one, we're going to get the text from the payload again. We'll say const text equals payload. And then what we're going to do is we're going to return the state. We're going to say return state with the to-do that we want to remove filtered out. And here's how we do that. We say state.filter to-do, and we only want our to-dos whose text property does not equal the text property that we got in the action payload. So that's the logic for our create to do and remove to do actions. Last but not least, we'll want to add a default case to our switch block, And for the default case, default, we'll simply want to return the state. The reason we do this is because our to-dos reducer will get called whenever any action gets triggered in our application. If our switch block makes it to the default case, that means the action that was triggered wasn't one that we're really concerned with, so we should simply return the state as it is. And we're going to want to remove this return state at the bottom. Now, once again, it's important to note that we do have to remember to return the unchanged state if our reducer doesn't make any changes, since otherwise, to Redux it'll look like our reducer is returning undefined and it will throw an error. Oh, and one last thing. Let's set the default value of our reducer to an empty array. The way we do that is by saying state equals empty array up in the arguments. And that's it for our reducer for now. Now that we have our to-dos reducer defined, we just have to actually add it to our application's store. And to do that, we just have to open up our store.js file, and we're going to import our to-dos reducer that we just defined. Import to-dos from to-dos/reducers. And we're going to add our to-dos reducer as a property of this reducers object here. And that's it. Our to-dos reducer is now hooked up to our Redux store. So far, we've defined some of the possible actions that can happen in our application and the effects that they should have on the state of our application when they're triggered. The next step is to actually give the components in our application access to the Redux store so that they can see what the current state is, as well as trigger actions that modify the state. The way we do this is by doing what's called connecting the components to the Redux store. And to do this, let's open up one of our components. We'll start with new to-do form. And up at the top, we're going to import a function called connect from the React Redux package. Import connect from React Redux. So here's how we use this connect function. Connect is what we call a higher order function, which in this case simply means that we call it with two different sets of arguments. Something like this. Don't worry too much about the details of higher order functions here. So the argument that we pass to the second set of parentheses is the component that we want to connect to the Redux store. In this case, it would be new to-do form. And what connect does is return a so-called connected version of that component. So instead of exporting our regular component here, we're going to be exporting our connected component that we define. So let's do that down at the bottom here. Instead of saying export default new to-do form, we're going to say export default connect, first set of parentheses, and second set of parentheses around new to-do form. So now that we've done that, we've seen that we pass the component we want to connect to the second set of parentheses. The arguments we pass into the first set of parentheses are where things get interesting. We're going to define two functions, one called map state to props. We'll say const map state to props, and it's going to take an argument called state, and for now it'll just return an empty object. And we're going to define a second function called map dispatch to props, which takes an argument called dispatch, and for now this is going to return an empty object as well. And then we're going to pass these two functions, map state to props and map dispatch to props, to the first set of parentheses of connect. Map state to props, map dispatch to props. So what do these two functions do exactly? Well, let's start with map state to props. The state argument that gets passed to map state to props is an object that represents the entire Redux state. In our case, it'll only have a to-dos property so far, but in larger applications it could contain a pretty large number of properties representing different pieces of data in our applications, such as users, videos, articles, and a lot of other things. Now, the job of map state to props is to take this state object and return another object containing the pieces of that state that our component needs access to. So in our case, we'll want our new to-do form to have access to the to-dos in our state, which will look like this. We'll return an object with the property to-dos that's equal to state.todos. And the cool part here is that because we passed both map state to props and our new to-do form component to this connect function, new to-do form will now automatically get the to-dos from the state passed to it as a to-dos prop. So we can add that up top here. And don't worry too much if this doesn't make complete sense yet. We'll be getting much more practice with this. So that's map state to props. Now let's move on to map dispatch to props. This function works in a similar way to map state to props, in that the properties of the object that we return will be passed to our component as props. The difference here is that instead of taking the Redux state as an argument, it takes something called dispatch. Now, what dispatch is it's a function that allows our components to trigger actions that our Redux store will respond to. In our case, we want to trigger a Redux action when somebody clicks the Create To Do button of our new to-do form. So here's what we're going to do. We're going to start off by importing our Create To Do action creator up top here. We'll say import Create To Do from actions. And then from this map dispatch to props function, we're going to pass our component a prop called onCreatePressed. And this is going to be a function that takes an argument called text and calls dispatch. And the action we're going to be dispatching is our Create To Do, called with the text argument, which will create a proper action object for us. And then we want to add this to our new to-do forms props object, onCreatePressed. And at this point, our component has all the access it needs to the Redux store. It can see the to-dos that are currently in the state, and it can dispatch an action to the store when we want to create a new to-do. All that's left right now is to make use of these two new props. So we're going to add some functionality to the onClick method of our Create To Do button. What we're going to do is add an onClick method to our button, and we're going to define an anonymous function here. And inside it, we're going to call our onCreatePressed prop with the current value that's in our text box. Remember that earlier we defined this input value state variable to keep track of the value that's in our input box. So we're going to call onCreatePressed with input value. And then after that, we're going to clear the contents of our input box by calling setInputValue. Remember we defined that up here in a previous video, with an empty string. Now, I mentioned earlier that we want to prevent the user from entering duplicate to-do text. So let's define a constant here called isDuplicateText. Const isDuplicateText. And we're going to use array.sum to see if there's already a to-do that contains this text. This will make use of the to-dos prop that we're now passing to our new to-do form component. So we'll say to-dos.sum, to-do, and we want to check if any of the to-dos in our state has text that's equal to the current input value. And now that we've defined isDuplicateText, we're going to create an if statement here. We'll say if isNotDuplicateText. Then we want to do these things. Otherwise, we don't want to do anything. So we'll copy and paste those two functions. Our new to-do form is fully taking advantage of Redux at this moment.